Alright, let's continue. And it happened that I have to introduce myself on my own because before I was hosting this session, but now I'm going to deliver you a presentation. Can you hear me well? Alright. So, Forward to the Past, it's a quiet allusion to a very popular film, Back to the Future, but I would like to go back to the past because of several reasons. One of the main reasons is when we update an application and the update is not correct. It's when you have some very significant bug and you are facing very serious problem and you have to restart from backups. You have to roll back your application. So it's just a very regular fuck up that you that always happens like 5 minutes before Christmas or something like that. Very similar things, maybe not so urgent, like your application is running for some time, for quite a while, and you would like to get some statistics. You would like to see what changed, number of operations, how they were modified. Sometimes security guys can ask you to do so. Maybe you got some malware or something like this. Sometimes it happens, and always happens, when a developer needs an older version and we give them some backup. Sometimes it happens that just for researchers you need to give something fresher, like 30 minutes before, and also it's a common dream for those who are working with production environment when you have to do something that will not bring any extra load. So as we take a glance at these tasks, there are only 3 points: to make it as it was, to see how it was, or to copy as it was. In fact, I remember Oracle flashback requests when you can go to the past. Sometimes in Postgres it could happen. So in a query of PostgreSQL, you could just define the timestamp to which you would like to roll back. But you understand that you don't have enough disks to keep a history of all changes and all modifications. So when we talk about these points to get back, to have a look, or to copy, we always say that we need to know this point in time. Of course, it is very difficult to define the exact point in time, so if you would like to get ready to these things, you need to define this period of time in the past or in the present or in the future. So as always, you know that tomorrow, today will be yesterday. So the solutions that exist, they are based on point-in-time recovery or on streaming replication or on PG dump, etc. That's good, but it brings extra load. Besides, we sometimes forget that they need to have a serializable level to get consistent snapshots, or just to stop writing operations, otherwise you will have problems. If you made a few PG dumps or several dumps, you need to understand the data in these PG dumps. They are common, but they are a huge amount of data and you store them separately because there are no ways to have incremental backups. With streaming replication, it's easier, but the problem is that you have to put it one on one, and if you would like to have a few replicas, you need more space, more machines, more admins. And if something goes wrong, the first thing admins do, they disable functionality they don't need. Streaming replication is okay. You have a backup for the beginning of the week. You would like to get a snapshot of yesterday's. You take this backup, you just roll up the snapshot. It's not always very fast, so sometimes you have to release some space. So it's a time-consuming process. The concept is very easy. Let's take a snapshot of a database. If you know the theory of databases, or you know what's inside Postgres, you know that snapshots exist. So if we're talking about transactions, we take a snapshot, and it is looking into the content of this snapshot. It is looking for uncommitted data and so on and so forth. But this is snapshot we can't control. We tried to make up another name. We tried to use it, but eventually we went back to snapshot, so it's one more snapshot. So just to make it different, we call it SnapFS. I will tell you conceptually how it is built without going into detail, and also I will tell you how it looks like externally. I'm not going to recall documentation once again or to show you examples. I will tell you how this can be used and how you can benefit from this feature. Okay, let's get started. Entity is snapshot once again. So it's it's a fully complete state with no uncommitted transactions. Have you ever encountered copy and write? 1, 2, 3, 5 people. Okay, I see that you know what's a copy and write. So the idea is, if we take a snapshot, in fact we just mark that the snapshot was there in the history. But if we would like to write a page, we need to do it separately, and we need to store an older version of a page. So when we put this tag, it's very cheap to do so. Of course, we would like to take the snapshots as last as possible, but the requirement for consistency seems for two options. It's either we put a tag and a history, and also we need to remember that at this point in time these transactions were running and we need to roll them back. It's not very convenient, because in this case you need to keep whole history piece just to be comfortable with your transactions, with your splits in trees and so on and so forth. That is why we have decided to make a very straightforward solution. We put a tag, we end the transaction, and then WAL is launched. So if in production you have long transactions, this snapshot can slow everything down, but we took into account a situation if you have long big transactions and they run constantly. You have OLTP or a lab that doesn't modify any data, and you can make it in an easier way. If you have these transactions, you won't see it, but if it happens every second, your admin will come to you and hit you in your head. But if you do it before update, just once before update, that's okay, not a big deal. Of course, when we take snapshot, it will include a block map just to understand where things are located. And when we will be using this snapshot, we need to know this page, was it changed, was it modified, or we need to read a previous version, because snapshots can be of different versions. But it doesn't actually affect the performance of the main thread. And as you know, Postgres Enterprise has compressed file system, and the idea is there is a block map too, and we took this idea out of it. So we are using this block map just to keep matches. So in a linear view, it looks like this. We have history, we have head, which is our current moment. It has snapshot number. It is always 0, like it's missing at all. And we have some snapshots in the history. We can switch between them very easily in read-only mode, just not to modify anything. If we would like to go back to read-write state, we take ID 2 and switch to ID 3, and you can see this gray arrow, it just disappears from our history, and the snapshot will disappear and the head will swap, and it will be ID 3 with a quotation mark. Just to give you a hint that it will be in a different point in time, maybe with the same objectives, but it will be a different snapshot, and you won't be able to get back to the original head and to ID 3, so you have a new history in place. If you know point-in-time recovery technology, the same approach must be familiar to you. Slow point-in-time recovery is very similar to what we are talking about right now. So timeline switches in the pretty much the same way. Now, so namely, it's about going back to the past. What makes me happy about this feature, I really wanted to have this functionality, operations with snapshots like creation, deleting there, writing to wall, with a very clear reason. If something happens bad, you just roll back. Snapshot must exist every time, regardless you reboot it or not. And if these things go to wall, you don't have to do a lot of manual operations to translate this operation to translate this behavior to snapshot. And also what we managed to do, and I will tell you more about this later, we managed to make snapshot operations now snapshot operations do not require reboot, so they are synced with master, and also they are in sync with replicas. What else? We can do 3 things with the snapshot. You can drop it, which is clear. Snapshot is not free of charge. You need some space to store the information about modifications. You can roll back one session. You can connect to a production database and you can roll back to a particular snapshot, and you will do it to a particular session. The rest will be in the past. At the same time, not to interfere with these things and just to make things easier, older version of pages go to local memory of backends, so they're not consuming shared buffers. On the other hand, it means that it is not very fast, but the objective was. not to damage production and not just to travel to the past in a comfortable way. So just keep it in mind that session will be slower. Next way how we can use this thing is to roll back the entire instance of Postgres, but only in read-only mode. So you go back, you can play in a several session, decide what's bothering you, switch to another snapshot in the present or in the past, and restore your read-write transactions. Frankly, I had a certain moment, I kept a certain model in my mind, but in fact, over all my experience, I know that things I write are never used in the way they were designed. So another way how these snapshots can be used is to roll back your database to snapshot state. So you roll back and this gray part just disappears. Of course, you do have some pieces of it on your disk, but over time they will be just overwritten. Alright, the interface of SnapFS is very functional. So you write a select, it is limited for super users only, and I'm afraid what regular users can do if they don't have super users rights, they can put you in a, let's say, unexpected position. So we have PG make snapshot function to create a snapshot. You can remove snapshot. Snapshots have IDs and not regular names. We would like to collect some feedback and maybe this feature will be modified. We just want to know whether you like it or not. You can recover to snapshot, which allows you to recover the entire database to a snapshot. You can switch to snapshot, so you change your database to the snapshot state, but keep it in mind that when you are switching to snapshot and you don't know how to go back and you are loading the database will be in the snapshot state, and replicas will be in this state too. Set backend snapshot, it's about setting a particular backend for snapshot. Get backend snapshot is about obtaining your backend snapshot. It's when you don't use switch to go to snapshot, you can use this one. But recover will be with ID 0 because after recover you will go to another head. And just a couple of features of SnapFS that allows you to see the size of snapshots, the timestamps, and so on and so forth. And don't forget that snapshots are okay, but you need to store data about snapshots. So if you make snapshots every day and you don't delete them, the database will be very big. So SnapFS is not a silver bullet. I believe that you can damage your application in a way that even Snapshot won't help you. I believe that most probably you will have cases like when you forgot to create a snapshot and you have nothing to roll back to. It's not a backup, it's not a protection against problems with disks. It can help you to create a backup. You create a snapshot and then with low priority, with low I/O, you can get the content by using pgdump or something like that. Base backup supports this backup at the moment. It's in the patch set. So you will copy it with together with the snapshot. And for the fourth time, I repeated that snapshot consumes some space and is growing with time. So once you create a snapshot, database doesn't increase in size because the state of a snapshot and the head, they are similar. With the first transaction, it will change at least 8 kilobytes, and then it will just grow. So, who was suffering over SnapFS? First, I was suffering of this. Konstantin Knizhnik made the major part of programming work. Roman Zhirkov was busy with testing, and Lyudmila Mantra was responsible for creating documentation. As far as status of this feature, in next Postgres Enterprise 11, this feature will be released, and in version 13 this patch will be released just to give it to community. Unfortunately, in version 12 we won't make it. The patch is too big, so we don't have any beliefs that this feature will go to version 12. Thank you very much, and now I can go back to my previous role as a moderator, and please ask your questions.
Two questions. Is it possible to recover and move the snapshot to the file network folder? This is one thing. The second question, is there a division of snapshots, full snapshots and incremental snapshots? Is it possible to make changes without making a copy? Unfortunately not. We focused on just keeping it working well in this state. Being incremental means coding computation of diffs between snapshot is not an easy thing, and it's not a quick thing, and it adds load to the system. So far the answer is no, we don't do snapshots, and we accumulate diffs in the head. Well, a snapshot is a copy on write, and it remains in the same directory. We're not sending it anywhere. So the change is taking place in the disks. On the disk, it is digested by the replica, but the overall concept is not clear enough yet. So you're trying to make snapshot, and it will show on some replica, but not on the master disk. Let's make sure this feature works well and everybody likes it, and then we will start improving it, and it will take a couple of years. So the numbering of snapshots, is it in order? It is +1. What if we delete the old snapshots? For instance, each day we take snapshots, and the snapshot of 1 week ago is deleted. So the numbering will go up. Yes, it will go up. Is there a limit? Do we have enough numbers? I think there are 32 or something. Well, 4 billion days or 2 billion days. Well, I won't live that long. So the last number of the last snapshot is taken, and so 1 unit is added, and then the new number is given. So thank you for your report. I think it's a very good feature. And where are the changes stored? Are we going to have a separate file next to the PG data? Yes. There will be a separate file with the snapshot files. The documentation, as soon as it is available, we will release it. So you can read about it in the documentation. Maybe at the next conference. We can deep dive in the design of it. And maybe we'll hear a report of the users who will try it. So the lines belonging to the snapshot, they are not deleted by vacuum. No, they're not. We had a concept of not deleting the lines, but when you have updates on the pages, you will accumulate lines not reflecting transactions but snapshots, and this will affect the productivity of the head. But if we make a copy of the page at the time, it was good, it looked good to us, then the head would operate normally, and it would not lead to the enlarging of the spreadsheets. So anything we need is in the old version of the page. So the long snapshots will not lead to bloating. No. That's why we would like to use copy and write pages. Bloating, we discussed it. We thought we would keep everything in place, but the original Postgres experience shows that it may lead to bloating, snapshot dropping. You can't really drop a snapshot. You can easily drop it, but then the vacuum should search all the pages because it doesn't know where the records were made and clean up everything. So this is the bloating itself. And also it would be strange to shoot the repacks. Then we'll have to teach the repacks not to delete lines or records from the pages. But the repack just reads a page, and if it knows nothing about the snapshot, it reads the latest version of the page. And also, if we roll back the whole instance, what happens with the current sessions? They're terminated. Well, you can't really do anything. So the rollback waits for the end of all transactions and delays the initiation of the new ones. So it happens in between the transactions. So we did it because we want to avoid issues during the switching. I guess we can discuss other things on the sidelines of the conference. Are we having a 4-minute break, or are we having the next presentation right now? 12 o'clock, Pavel Luzanov. So the rest we can discuss over lunch, because I'm going to stay here, or just on the sidelines. Thank you.